frustrating to see, but by stitching together every fragment of sensory input into a seamless experience. Today we embark on an immersive journey through the landscape of neuroscience and perception, where the mind's inner workings meets the marvels of the scientific inquiry. Imagine your brain as a crowded metropolis, with billions of neurons competing with each other and shaping your reality with every single thought, sensation, and a mind full of sensations. But what we perceive isn't always what meets the eye. It's a dynamic interplay between neural networks and the intellectual processing. Let's start this journey with a fact. Your brain isn't merely a passive receiver of information. It fills in gaps, makes assumptions, and occasionally deceives you through fascinating optical illusions. And your brain processes visual information a staggering 60,000 times faster than text. It's like a lightning-fast supercomputer, effortlessly decoding the world around you in milliseconds. According to the National Institute of Child Health and Human Department, the nervous system comprises the central nervous system, consists of the brain and spinal cord, and the peripheral nervous system, which includes the nerves outside the central nervous system, connecting it to the rest of the body. Neurons, the fundamental units of the nervous system, transmit electrochemical signals through axons and synapses, providing communication between cells. Neurotransmitters such as acetylcholine and dopamine mediate signal transmission and synapses as well. The brain is organized into regions for different functions, including the cerebrum for higher cognitive functions, cerebellum for coordination, and the spinal cord for basic physiological functions. The spinal cord serves as a pathway for motor information and transmitting sensory reflexes. Plasticity allows the nervous system to adapt and reorganize. That's your brain's remarkable ability to prioritize and filter sensory input, ensuring a coherent and perceptual experience. Did you know that taste is heavily influenced by smell? Close your eyes while eating a meal and suddenly the flavors become more elusive. Or have you ever wondered how you can hear someone speaking in a very crowded room? And that's one of the filtering systems too. For instance, according to the University of Cambridge, after losing a limb, some individuals experience a sensation called phantom limb sensation, where they feel sensations such as pain, itching, or movement in the abdomen. This phenomenon highlights the plasticity of the brain, as neural circuits originally dedicated to that area, dedicated to the missing limb, can reorganize to process by nearby areas. Studies have also shown that in professional musicians, they have enlarged areas of the brain associated with other processing and motor control, unlike us, like non-musicians. This structural difference shows the brain's ability to adapt to extensive training and repetitive practice. Another interesting fact is in people who are born blind or lost their sight early in life, the visual cortex can undergo reorganization to process non-visual information. This rewiring of the brain repurposes unused senses in areas to accommodate other functions. Reality is often an illusion. Take the rubber hand illusion, for example. It's a striking demonstration of the brain's pliability and familiarity to manipulation. By synchronizing touches on the fake rubber hand and your real hand from hidden your view, your brain can be tricked into thinking the rubber hand as your own. It's the pliability, as I said. Research has shed light on the demonstration of neuroplasticity mechanisms, and these discoveries hold promise for developing innovative therapies for neurological disorders and enhancing cognitive function in healthy individuals. Our burgeoning understanding of perception holds an immense promise for our future. Neuroscience is poised to catalyze groundbreaking innovations in health, from developing treatments for neurological disorders such as anxiety, depression, or schizophrenia. As you can see, people who are stressed or depressed haven't got that much of brain activity. Their MRIs aren't colorful as the normal people. Or with the people with schizophrenia, the visual cortex can undergo some changes. This is why they have neurological disorders. Neuroscience with perception can help to develop treatments for their disorders. However, as we tread further into the frontiers of neuroscience, ethical considerations loom large. Advances in neurotechnology raise complex questions about privacy, autonomy, and the ethical boundaries of manipulating perception and cognition. We must navigate these ethical boundaries with deliberation and foresight, ensuring the principles of beneficence, justice, and respect for human dignity guide scientific progress. In addition, recent neuroethics developments have underscored the importance of interdisciplinary collaboration, where the ethicists, neuroscientists, stakeholders, and policymakers work together. As we conclude our journey through the captivating realms of perception and neuroscience, let us marvel at the intricate tapestry of human life, from the lightning-fast computations of neural networks to profound implications for education, healthcare, and beyond. The journey of exploration continues to ignite curiosity and inspire awe. So the next time you behold the world around you, remember that the reality of you is just a glimpse of your brains and the boundless universe. Keep exploring, keep questioning, and keep marveling at the mysteries of perception and neuroscience.